So I emailed everyone worksheets. We're on the fourth week. So what we're going to start with is perimeter and area, and then we're going to look at basic shapes, and then we're going to look at composite shapes. Okay. Now, so let's talk about the difference between area and perimeter. So when we're talking about area, we're talking about how many unit squares are inside of the rectangle. Let me showcase this. Give me 1 second. There we go. Okay. So they're talking about the amount of area that is inside of the rectangle. Now, when they're talking about perimeter, we're talking about the distance around the shape. So this is what describes the outside. And then this describes the inside. Now, sometimes they won't say area, and sometimes they won't say perimeter. Sometimes they'll talk about how much carpet do you need, or tiles do you need, or grass do you need, or seeds do you need? Something that you lay or spread inside. Okay. Now, in terms of perimeter, sometimes they won't say perimeter. They'll describe it as a sidewalk or a walkway. How long? A walkway, a fence. Sometimes they'll talk about a baseboard. What a baseboard is if you have a, think of this as your floor and your wall. The baseboard is right here. It goes along the side between your floor and the wall. So sometimes they don't match. There's a little crack in between. You hide it by putting a little piece of wood there and painting over it. It looks like a pretty little trim, but really it's hiding the crack between the floor and the wall. Baseboard, walkway, fence. Yeah, these are the most common ones. So when they talk about walking around something, they're talking about perimeter. Now, when we're talking about circles, they won't call it perimeter, they'll call it circumference. And the circumference is going to be equal to 2 pi r. So r is the distance from the center to the outside. So that's r. Okay. That's your radius. Now I wrote a whole bunch, so let me give you a chance to catch up a little bit. Now, they may also give you the problem and tell you what the diameter is. The diameter goes from one side of the circle through the center to the other side. Okay, that's my D. So just know that radius is equal to the diameter divided by 2. So if they give you the diameter, to get the radius, just divide it by 2 to get R. Okay. So know that circumference is basically perimeter. How long, like if this was a piece of string, and I cut the string, and then I pull the string, how long is that string, right? So circumference and perimeter, they're together. Okay. And if we wanted to look at the area of a circle, then let's see. Okay. So we're going to use the same R. Is equal to pi R squared. Let me get a black pen out. So let's pull this in. Okay. So one of the nice things about having a multiple choice question on area or perimeter is that what will happen is that, so let's say we have find the area. Let's call this 5. Okay. Go ahead, do that, and then it'll say use 3.144 pi. So go ahead and do that. Plug it into this formula. So go ahead and plug it into here. Okay, and figure out your answer. get A is equal to 78.5 feet squared. Okay. Now, because you're taking a multiple choice test, when you see the square, you know that the question is asking for area. So because it's a multiple choice question, you can look at the units, and if you see a square there, you know, oh, they're asking for area. So if they had asked me in a different way where they said, how much carpet does it take to lay in this shape? Or how much carpet, how much floor does this circle carpet cover? And you're like, I don't know, what are they asking for? Is that area? Is that perimeter? What is that? You can look at the units of the questions, I'm sorry, of the answers, and if you see a square there, you can know immediately, like, oh, if they're asking for area. Now let's look at the units for circumference and perimeter. Okay. So let's look at how much fencing should you buy to surround your garden we'll make this meters. Okay. Now you want to ask yourself, fencing, is that inside or is that outside?
Outside?
Outside, yeah. So it's going to be circumference. So go ahead and do circumference is equal to 2 pi r. Okay, and go ahead and use 3.14 for pi. So this is going to be 2 times 3.14 times 10 is equal to 6.28 times 10, 62.8, and then meters. Now, because there's no square here, we know that this right here is circumference or perimeter. Now, what they may also do is they may also give you partial shapes of a circle. So for example, they may say, find the area of the shaded portion of the circle. They may give it to you like that, or they may just give you a quarter circle like this, or a half circle. Usually it's going to be a quarter half, something that you can sort of recognize. Maybe they'll say this is 6. Let me give everyone a chance to copy. Okay. Now, in order to find this circle, when we look at this, we can see that this is 1/4 of the circle. So what you want to do is take the find the area of the entire circle and then divide it by 4, right? Because this is 1/4 of the entire circle, right? So this area is equal to the area of the circle divided by 4. So go ahead and find the area of the circle, this entire circle, okay, and then divide it by 4. Let me put a unit on here also, just so we get used to seeing that areas are something squared. So we should get pi r squared divided by 4 is equal to pi 6 squared divided by 4 is equal to pi 36 divided by 4. So these are not Siamese twins. That 36 and 4 are separated by a multiplication. So you can just simplify that is equal to 9. We'll put the pi at the end. Now, if you want, this may be one of the answers, or they may want you to multiply it by 3.14. Since it's multiple choice, you can just look down and see whether they want it with pi or with times it by 3.14. So I get 28.26. Okay. So go ahead and copy that, and then let me put the next question. Oh, and then this should be inches squared because it's area. Try doing that last problem. Okay, now there's a few tricks here. A little more, there's a little more to consider than what we had over here. First of all, there's two pieces here, right? One is we have to find this length. And that length is the circumference divided by 2. Plus, we also have to add this part right here, that line. See, when we do the circumference, It only gives us the circle part. It doesn't give us the line across. Now, remember that when we are computing circumference or area, we need to have the radius. So over here, they gave us that's 20 yards, but really, when we do the computation, it's just supposed to be 10, because this right here is my R. Okay, so they had given us the diameter in that case, and what we want to do is we want to cut it in half. Okay, so figure out what this is, and then add the 20, that is this part right here. So you get 2 pi r. R is going to be 10. So your answer could be, when they cross this out, 10 pi plus 20. That's one answer. Or they could give you, they could factor out the 10 if they wanted to be cute about it. Or they might want you to plug in the 3.14. And get 51.4. And then the units would be yards. Now, if you were to ask me which one they would probably give you, my guess is they would give you this one or this one to be cute. Let me give everyone a chance to copy. Let me make sure I took a picture of this. Okay. Now let's look at the area of triangles. So we have area is equal to 1/2 base times height. So base is one side of the triangle. And the height should form a right triangle with the base. That's poor grammar. Well, it should be the base. So there are basically three kinds of triangles that you can find areas for. Something that looks like this, something that looks like this, and something that looks like this. Now, to find the perimeter, you just add the sides. Now, let me put some numbers on all of these. Okay. Now, the key thing is that the base and the is going to be one side of the triangle, and the base and the height are going to form a right angle. So when we have something like this one's not too bad. We can see that this is the base, and the height is, when I draw a right angle, what is the furthest point from this line? So that's the furthest point, like that. Okay. So that's my base, part of the triangle. That's my height. It forms a right angle, and it goes to the furthest point. Now, same thing over here. The only right angle I see is that right there, which means that, okay, if we go by what I said, one side of the triangle is the base. So this right here is my base. And if I say, okay, now I need a line that is the furthest distance from this base that's a right angle, well, then that's going to be right here like that. Now, this is the hardest one because it's not that intuitive. The only right angle I see is right here. That's my only right angle. Okay. Now, that's my only right angle. So when I want to look at, so this right here has to be my base. Okay. Now it doesn't extend to here because it's one side of the triangle. Okay, so it's this one. Now, if I don't want to know what my height is, it's right there. So this one's a little weird because the base and where this height, that line, they don't actually touch each other. Okay, but if I were to say from this line, what is the, I draw a right angle, what's the furthest point? Right here. Okay, so go ahead, using the red and the green, use this formula to figure out the area of each triangle. So this one's going to be 1/2 4 times 3 is equal to 2 times 3 is equal to 6. This one's going to be 1/2 4 times 10 is equal to 2 times 20 is equal to 40. Oh, is that right? No. 2 times 10 is going to be 20. Okay. All right, so that's good. This is good. And this over here is going to be 1/2 times 4 times 5 is equal to 2 times 5 is going to be 10. Like that. Okay. Now, I'm going to let this settle with you a little bit. And I want to hit something else before we lose too much time. And then once we finish that, we may come back to some more of this geometry. Okay. Let me take a picture of this. Okay. Now, so this was area. Now let's pop open. And let me see. Let me write down who's here right now. Give me a second. Okay. Now let's look at some of the worksheets that I sent you. Okay. Let's see. So let's share screen. And these are also available on the Haiku. Okay. So what I want to do is work on these covariance examples. So go ahead and pop that file open. Let me get my phone. And my caffeine. Okay, yeah. Okay, so let's pop this open. It looks something like this one. Okay. Now, correlation and covariance, they're not the same thing in the statistics class, but in the TEAS exam, think of them as the same thing. Okay. So what correlation and covariance try to measure is when something goes up, does something else go up or does it go down? Is there a relationship? So for example, if we were to talk about, let me sort of annotate it. If we were to look at the amount of fat that you eat, okay, and over here you were to look at your weight gain, and we were to say, okay, so the more fat that I eat, right, the more French fries I eat, the more weight that I gain, we would end up with a line that looks something like this. Not exactly, but something like this, right? So something like this has a positive correlation, meaning that when this is positive, this is positive. Okay. Now, the closer this looks to like a line, like these are all samples, like I ate this much fat, this is how much weight you gained, right? Now, the closer this becomes to a straight line that goes up. Now, when we're talking about up, we're talking about looking at this from left to right. So when I say it's up, I mean going left to right, it's going up. Okay. Think of it as slope. When we're going slope, we get a positive slope. So the closer it is to a line, and it doesn't matter whether it's up like this or up like that. Okay. The biggest value correlation or covariance can have is 1. So as long as we're going up and it's a 1, up and it's close to a line, the covariance and the correlation is equal to 1. Now, the more fuzzy it gets, so this is kind of line-ish, but still looks like a line. It still looks like sort of a fuzzy line going up. The number gets a little bit less than 1. Now, when you just get just sort of randomness, or you get these weird shapes that have nothing to do with a line, the covariance and correlation are equal to 0. Okay. Now, the same thing happens with if there's a negative correlation. So over here, we have a negative correlation. So for example, if I were to say use two different sort of variables. So if I were to say, the more exercise I do, the less weight I gain, right? So if I don't do a lot of exercise, I gain a lot of weight. But the more exercise I do, the less I gain. So this is a negative relationship. So if I get a line that's going down, again, we're talking about going left to right. Okay. So if I get something that goes down, that's a negative one. Okay. So you want to sort of just kind of like look at this right before you take the test. It's a nice thing to, like, you should be able to look at it. And as soon as you see the word covariance or correlation, say, is it a line? Is it up or down? Done. Okay. Now, if you get a horizontal line, that's the special case where this is undefined. Now, the other way they may ask you the question is as a word problem. They may ask it like this. The more you exercise and the amount of weight you gain, is that a positive or a negative correlation? Right? And you have to sort of do it in your head. Well, when I exercise more, do I gain more weight? No, it's the opposite. So this is negative. Oops, sorry. Okay. So they may say the word negative correlation. In the same way, they may say in a word problem, the more fat I eat, the more weight I gain. That would be a positive correlation. Because when the fat goes up, the weight goes up. Okay. Although who knows these days with Atkins and all that kind of stuff, who knows? Okay, so does anyone have questions on this?
No.
No, you go, okay, all right. So that one should be a quick kill. Like you should be able to see it and then jump on it and then have extra time for other problems. Okay. Now, the next one I want to get to is this distribution shape worksheet. Okay. Okay. Now, before I get too far in this, okay, let me write down draw what each one of these things are. Okay. So let's clear this, at least on this side. So we're looking at a distribution. So I sample a whole bunch of people and I sort of list them in groups. So over here, we call this a normal curve. Now it doesn't have to be, I mean, really, I don't really need that right there. It's just the shape right there. So this is, it doesn't need to be near zero. It needs to be under, doesn't need to be near zero. So this is a normal curve. Or I guess we should call it distribution. Or they call it a bell-shaped curve. We'll call it a distribution. Sometimes people call it a curve also. Okay. Now, if we have something like this, this is unimodal, meaning that I have I have one peak. So it could be like this. It doesn't necessarily have to be normal. I can have something like this, which is bimodal. 2 peaks. And then I can have something like this, where this right here is a gap. Meaning I have a whole bunch of people here and a whole bunch of people here, nothing in between. That's a gap. I can have most of my people here, and then I can have a little blip far away. That's an outlier. Someone that is very different from everyone. Let me check something. Okay. Now this is the one that's hard to remember. If I have a distribution that is pushed to the right, we call this skewed left. So this part is smaller. Okay, everyone's pushed to the right. And then if I have everyone pushed to the left, this part is smaller, this is skewed right. Okay. Okay, yeah. You can give everyone a second to copy. Okay. So let's share screen. Let me make sure I copied the board. Did I take a picture? No, I didn't. Let me take a picture. Okay, now let's open up that worksheet. Let's see here. We're going to open up distribution shape worksheet. And just so you know, the answers are on the bottom. Okay. Now, the ones I care about, okay, when we do this, I want to know whether they are symmetric, skewed right, skewed left, bimodal, outlier, and gaps.
I think it's freezed. We can't see your sharings.
Uh-oh, okay. Let me see, thank you. New share. Okay, is that better?
Yes.
Okay, thank you for telling me. Okay, so I want you to consider for these shapes, is it symmetric, skewed left, skewed right, unimodal, bimodal? If there's an outlier and are there gaps? I also want you to consider if it is a normal distribution. Okay. So tell me which characteristics match this one.
Which one?
This one right here, the top left.
It's normal.
Yeah, okay, so it's normal. Uh-huh. What else is it? It's symmetric, roughly symmetric, right? And it's, oh, I'm sorry, two M's. As long as it's roughly symmetric, that's fine. They're not going to be exactly. And it's unimodal. Okay. So go ahead and do the other three, and then we'll compare notes. So let's give everyone a second to try it, and then we'll compare notes. So this one is bimodal.
Bimodal.
Yeah, symmetric. And I think that's it. This is the one that's confusing, right? So the small side is on the right. So this is skewed right. Right. Yeah.
Can we say gap also?
Say no gap.
No.
Gap means that there's a space between. Yeah. So we'll have a gap in a second. So this is unimodal. And this is
to the left, skewed to the left.
Skewed left, yeah. And unimodal. Okay. So let's take this picture. Okay, so let's do the same thing again. So let me clear everything. Let's go down to, go ahead and do this bottom one here. So this one would be bimodal, and we have a gap. Now, the only common one that they haven't discussed, shown you, and let me draw it for you here. Okay, so the only one that's very common that they haven't shown you here, let's draw it like, is what's called a constant distribution. So let's So a constant distribution means no matter what, everyone's the same. So for example, if each one of these on the X was the age, and this over here is how many students, this would be for every age, we have exactly the same number of students. So this is called a constant distribution. And it just looks like a square. Okay. And then this would also be symmetric. Okay, let's take a picture of this. Okay, we made a good run. Let's take a 10-minute break and then we'll finish this one. And I have a covariance correlation word problem worksheet that I'll work through with you. Okay. And then next week we'll continue on with some of the geometry. I just wanted to let it sink with you over the week. Okay, so let's take a 10-minute break. Okay, thanks everyone.
Okay, let's get going. Let's see, where are we? Okay, so let me make sure I took a picture of this. Yeah, I did. Okay. Now let's do some more problems here. Okay, so let's move down. Okay. So try, all right, so don't say it out loud yet. Give everyone a chance. Look at number 7 and tell me how you would do this. Okay, does anyone know how they would do 7? Okay, so the way you do 7 is that you would just add the heights of each one of these boxes. So over here is number of students. So over here, you'd say about 4 got between a 0 and 20, about 9 got between 20 and 40, about 20 got between 40 and 60. So let me just type that, right? So there's probably about 4 here. There's probably about 9 here. There's probably about 20 here. There's probably about 40 here. And let's make this one, I don't know. So if I was to guess how many students, I'd say something like 4 plus 9 plus 20 plus 40 plus 22 is 82, 91, around 85. Again, that's an estimate. Okay. Okay, now look at number 8. Does anyone have an answer? So this graph says that there are 10 students who have a height between 75 and 80. That's all it says. It doesn't say that one student is 75, one student is 76, 3 students are 77. So let's say no. The, oops, sorry. The histogram shows only that 10 students are between 75 inches and 80 inches. Okay. So let's keep going. So let's clear everything. Let's see. I'm not sure what that SOCS is. Let me look it up real quick. So go ahead and do the lowest price, and let me see what SOC is if we have to care about it. Oh, okay. So So the question, so SOCS stands for the shape, bimodal, unimodal, normal, skewed left, skewed right, outliers. Is there anyone that's way far away from everyone else? Center and spread. Okay. So the lowest price is 50 cents and the highest price is $4. In terms of shape, I would say bimodal. I don't think this is an outlier because there's a bunch of people grouped together over here. The center is probably the center of the number of people. So I have 4, 6, so that's 10 people over here. 13, 16, 18, 19. So the center is going to be around the 9th or 10th person. So that's going to be around 150. Okay. And I'm not sure what the spread is. The spread might be from 50 to $4, 50 cents to $4, but I'm not sure. Okay, so let's clear this. Okay, and then I think we're okay. Okay, so I think we're good with this one. Okay, now let's do the covariance and correlation. And let's remind ourselves, right, of covariance and correlation. So we had this one right here. So remember that when we have a line going up, it's 1. A line going down is -1. And if we have a line that goes up-ish, the more fuzzy it is, the closer it gets to 1. Okay. And if we have random shapes that are not aligned, we consider them 0. And if we have a horizontal line, that's undefined. Okay. Now let's do some harder correlation covariance questions. So let's go to, so I shared this with you. It's also on the haiku. So you can look right here on the correlation worksheets. Okay. So let's make this a little bit smaller. So we see it all at once. Well, maybe a little bigger. Let's see. Oops. Okay, that looks pretty good. Okay, so let's look at number 1.
I think it's again freezed. We can't see your sharing.
Oh, we can't see it again? Okay, let's see. Thank you. Okay. It's okay. So go ahead and read these and figure out if you can understand which answer it is. Now, the key thing to understand in these things is that the x-axis is the driving factor. That's the driving factor. So you should be looking for something that says, as average traffic increases, what happens?
Vehicle speed decreases.
Decreases, right. So that's going to be this one
B1.
right here. Yeah, it's going to be B. Okay. Now, does this have a positive or negative correlation?
Negative.
Yeah, negative correlation. So if they're to ask you, what's my correlation here? Your correlation is probably, it's kind of a line-ish. Maybe you would say correlation is around negative 0.8. Something like that. It's not a line, so it's not one, but it's definitely a line-ish. Okay. So go ahead, look at number 2. Anyone have a guess on this one?
I think the graph shows no trend.
No trend, yeah, because there's no line,
Yeah.
right? So there's no line there. So if you were to type the correlation or the covariance would be about 0. All right, so let's clear everything. Okay, so let's make this a little bit smaller. Give me 1 second. That goes there. Let's see if we can show all these graphs. No? Okay, so just read the answer, which shows a positive correlation between number of hours studied and test scores. Okay. So which one shows the best one? The best correlation?
A.
A, yeah. Because when I study more, my test score goes up. Over here, this is a negative correlation, right? So if we were to write this in terms of correlate, so this right here is my answer. This one here. Oops. That right there is my correlation. That's my answer. Now, over here, my correlation would be about 0.9. Over here, my correlation would be negative 0.9. Over here, since it's horizontal, it's probably 0. It's not quite a horizontal line. It's kind of a fuzzy horizontal line. And over here, it would also be 0. Okay, so the one that shows the best correlation between more studying and higher test scores is that one right there. Okay, and now let's look at this one over here. It's clear. Just make this a little bit bigger. Oops. Okay. What do students think?
The D one,
Yeah,
more ticket
so,
writers.
yes, you've seen it correctly. So the thing that drives this is this right here. As this gets bigger, what happens? So as we get more ticket writers, we don't get fewer tickets, okay? There were 50 tickets issued each week. That's not true. If it was, then we would have all our dots here. When there are 10 ticket writers, there will be 800 tickets. That's not true. When there are 10 ticket writers, right? When there are 10 ticket writers, if that was true, we'd have a dot right there, but we don't. That's why our answer is going to be D. Okay, so let's go down a little bit more. Okay, let's do two more and then we'll go back to some geometry. Okay, so go ahead and do number 5. Okay, what do people think?
No correlation.
Well, look at this. This kind of looks like a line, right? See how that looks like a line? So it
it's
doesn't have to be a,
positive.
huh?
Positive.
There you go,
correlation.
positive correlation. Yeah, you got it.
So if there is no line, but still you see that you can make a line, it means that there is a correlation, correct?
Yeah, yeah. As long as, so if we look at, yes, yes, you're saying it correctly. So it could be line-ish. It doesn't have to be an absolute straight line.
Okay, thank you.
Uh-huh. No, try, go ahead, look at this one.
The last one, the water temperature increases as the heating time continues.
Okay, so let's see. So this is the driving factor.
Mhm.
So as heating time, let's see. The water temperature remains the same. No, it decreases now. Yeah, you're right. It's D. Yeah.
Okay.
Okay. So let's take a picture of this. Okay. So going back to the point we made on this one, let me sort of take another show you one more show you this one more time. So let's look at let's get rid of, let's do a new share. And then let's look at, give me 1 second. This right here. Oops, sorry. Mouse, then, oh, that's not the one. Then let me new share with you. Give me 1 second. Doesn't want me to. Give me 1 second. Oh, here we go. Oh, give me 1 second. Let me get out of here. Let me just stop sharing and let's try it again. Give me 1 second. so that's what I want. Okay. And then let's share. Okay. So I want you to see that all of these have a positive correlation. Okay. So even though it's not a line, but if it's like roughly pointing up, even something like that, we can sort of see a fuzzy direction. Those are all positive correlations. Okay. And then over here, all of these have a negative correlation. Actually, I should draw it this way. Let me erase this. Okay, so all of these have a positive correlation. Oh, shoot, I messed it up again. These 6 right here have a positive correlation. So it can be fuzzy, and we don't care about the slope. As long as it's pointing up just a little bit, that's a positive correlation. Now over here, even if it's fuzzy and even it's pointing down just a little bit, that's a negative correlation. Right, so it can be fuzzy. Okay, so let's take a picture of this. Okay. Okay, now let's go back to a little bit of geometry. And then if you have stuff you want me to cover, just be sure to email me. And I'm more than happy to cover things that are specific to what you struggle with or what you have anxiety about. Now, let's look at composite shapes. So shapes that combine each other. So let's say I give you something that looks like this right here. So this is 10, this is 4, this is 7. And let's make this 2. So you don't know this length, and you don't know this length. So I want you to do 2 things. I want you to find the perimeter. And then I also want you to find the area.
Now, in order to find the perimeter, I need to know the length of all the sides. Now, the big hint is look at the sides that are parallel to this side. So for example, if I look at this right here, and look at this right here. So that's 4 and 2. So we can see that this up here is 4. Over here is 2. So 4 plus 2 is equal to 6. Now do the same thing over here. This longer side is 10, and the shorter side is 7, right? And these are parallel to this. So see if you can figure out what that is. So now this is this right here. Okay. Now the longest side is 10. The shorter side is 7, right? It should be this plus this will be equal to that, right? This length plus this length is equal to here. So up to here, that's 7. So the question is, what's that over there? So that's 10 minus 7, which is 3. So let's redraw this shape without all the little markings. Okay. I have 10, 4, 7, 2, 3, 6. So this is equal to, the perimeter is equal to 10 plus 4 plus 7 plus 2 plus 2 plus 6 is equal to 21, 25, 31. Now, go ahead and see if you can find the area. Okay. Now, you don't know how to find, you've never been taught to find an area of something this shape, but you can cut it like this, or you can cut it like that to make it into 2 rectangles. Okay, so make it into 2 rectangles, find the area of both rectangles, and then add them together. So I'll try cutting it here. But you could have just as easily cut it there. Okay. So when I cut it here, the lengths that matter is this one and this one, right? Because this 10 goes all the way to the bottom. And over here on the bottom, the lengths that matter is this one and this one. Okay. So when I cut this, this turns into 4, 7, and then over here, 2 and 6. So the area of this one is 28, and the area of this one is 12. We just multiply them. So we see the area is equal to 28 plus 6 is equal to 34. Okay. Now, before we go into the last example, I want to talk about what's called the Mighty Mouse. Technique. Okay. This was discovered by a Israeli professor. Okay. Now, if I was to take a test written by just an average non-professional teacher, not a non-professional teacher, a teacher who was a non-professional test maker. Like their job wasn't to make tests. They didn't study the science behind tests. The most common answer would be C. And it's just sort of human nature. You have one trick question above, one trick question below, and then you have the answer, and then you have a throwaway question. Now, students have learned that C is the most common question to guess. And if you're not sure it's C, then you do B. Okay, A and D are the least often for an average teacher. Okay, so if you're ever taking a multiple choice test and it's just a regular Joe teacher, and you don't know, and you have no choice, you can't cross anything else, C. If you're able to cross out C because you know, oh, it can't possibly be C, B. Okay. Now, professional test makers know that good students know this little trick. So what they try to do within each section of an exam is they try to have the same number of A's, B's, C's, and D's. So they try to split it out even. So they go, ha, you can't get C anymore. Yes, but now there's a different technique that you can use. So what happens is while you're doing your test, every question that you are confident in, every time you go like, oh, that one's right, just put tick marks. So as you're going through the test, and then you get to a question that you absolutely don't know. Now, the problem with the TEAS exam is that usually it's on the computer. Now, if you have a choice to go to a testing center that allows you to do it on paper, take the paper test. The reason why is that if you take a paper test, you can leave it blank and go backwards very quickly. You can just write down all the ones that you don't know. And then when the time is running out, you go to the ones at the end and you can just fill out everything, D. And you have a lot of information because the rest of the test you filled out. Okay, you would just make everything D's because compared to the other questions, guess what? There are more D's out there than anything else. So just marking everything D gives you the most guessing points. Okay. Now, the problem with using the computer on the TEAS is that students have told me that it's very difficult to traverse backwards. You can, but it's time consuming and painful. So when you go through the TEAS, make sure that as you march through each question, be sure to answer each question. Even if you don't know, use this technique to guess, but on a separate piece of paper, write down the ones that you want to go to. Now, there is a priority in which you answer questions. The very first priority is questions I know. That I can do fast. 2, questions I know, but take time. 3, questions I'm lost on. Okay. So the key is this. As you go through the exam, that's your bread and butter. You want to make sure you spend your time on the questions that don't take a long time that you know you can do. Don't blow those. You only need to get around just over 2 out of 3 questions right. Okay. Now, depending on how much time you have left, you may have to skip these and just guess, just because I don't want to run out of time. So you might want to guess and then come back to it. Okay. And for these, what you want to do is guess right away and then go. You want to save time on these to be able to do these. What happens is that students get, if these are in the beginning of the test, what will happen is that students will get stuck and go, I don't know. Is the whole test like this? Oh, I'm really stressed out. I don't know. And they'll sit on the question that they're not sure about. You don't want to do that. What you want to do is go, I don't know. I have no clue. I'm going to save time so I can do this. So on the questions where you go like, oh, who the hell knows? The worst thing you can do is spend a lot of time and get it wrong. What you want to do is like, who the hell knows? I'll guess. I have a 1 in 4 chance of getting it. And by skipping this one really fast, I have double the time to work on this problem. Okay, does that make sense for everyone? Okay.
Yes.
Now, okay, so now remember, in terms of your guessing, that's your technique. Okay, so when you go to the, when you ask the people who make the test, so let's say you ask ATI or you ask the people who make the SAT, they all deny that, like, oh yeah, we don't balance letters in a section. But this Israeli professor went back and just started like looking at old SATs, like, yeah, you say you don't, but yeah, you do, because I just looked. So, okay, thanks everyone. Thanks for working so hard. I appreciate how hard everyone's working. Okay, and we'll see you guys next week. Hang in there.
It's cutting off.
Yeah, but thank you, everyone. I'll see you. See you next Friday.